So our first talk of the afternoon is from Gautam, and he is from Oak Ridge National Laboratory, and he's going to be talking to us about curating planet-scale location intelligence for humanitarian missions.
Hi, good afternoon, everyone. I'm Gautam Thakur, R&D staff scientist at Oak Ridge National Lab. I want to really take a moment to thank Cleo and Yasmin to really put together this fantastic and I'm learning a lot from the academic perspective and opportunities to do research using POI data. So today I'll take a little bit different perspective in terms of how researchers and practitioners of POI data can utilize this kind of data towards humanitarian missions. And this work that I'm going to present today is achieved through heroic efforts by a lot of people, from researchers, geographers, computer scientists, data engineers, infrastructures, and I tried my best to put together the names here. And I'm sorry if I could have missed someone, but it's a real pleasure to kind of part of an amazing team who does kind of a tangible work here. So when you look at some of the disaster challenges that we have as of today, like the top right corner, you see the recent explosion in Beirut, Lebanon, or the one at the bottom is the Bahamas hurricane that happened. Two things you basically always get mentioned. One is how many people are affected and what are the places or infrastructure that's damaged and how many billions of dollars of damages that were happening. So these two always get mentioned, and one of the most critical aspects of any post-disaster recovery is actually to enact in the shortest possible time during the disaster or as soon as the disaster happens, so that we can activate first responders or kind of medics and other people. So that time frame of between 0 to 48 hours is the most important time when most of the things can be saved or can be mitigated. And other challenges that we have during this is sometimes the situations evolves over time. So how you can kind of get this dynamics captured as soon as disaster happens, but at the same time you share this information with people who are on the ground. And another big challenge is these disasters, of course, even with preparation, can happen anytime and anywhere. So how we can prepare ourselves so we can be at the forefront of people supporting these kind of activities in support of saving lives and saving resources. So here at the lab, I'm part of a program that basically advances the collection, curation, and distribution of high quality points of interest data, very rich attribution, and in order to mitigate and prevent some of these disasters, and as well as create kind of resiliency within our infrastructure as well. Not only that, can we also estimate and ballpark on what if these infrastructures look like before and after a disaster. And besides disasters, you might have, some of you might have first-hand experience of looking at some of the stadiums or big conference centers being converted into temporary shelters during the pandemic. So how you can even without a disaster can use this kind of infrastructure towards or repurpose them in some different settings. Besides that, without this, can you use social media data like Twitter or news and other forms of data towards improving our understanding of what's happening and then kind of incorporate that into creating these kind of data sets? So I'm part of a program called Planet Sense here at the lab, and the main emphasis of this program is basically to look for non-authoritative data, like data that people share on social media, but also like, hey, if they're opening a restaurant, for example, and they have an advertisement or a page on Facebook or on Google places, and this kind of crowd contributed data, can we utilize that besides buying some of the highly good data like Dan and Bradstreet, for example. And once you curate these data sets, can we make that data available to people who are on the ground, like first responders, for example, or geoanalysts? And can we do that at scale, basically for the entire planet? So this program really kind of make an tangible effort towards achieving that. And there's a lot of research that comes because of this kind of an effort from developing like ontologies or conflating different data sources, kind of creating confidence in POI data when you cannot be there. For example, how about the restaurant in Mali? How much confident you are, for example, that there's a restaurant in Mali without going there? So those kind of challenges we deal with as part of these programs, and it's part of supporting some of the data collection. So really the vision for this research, or as part of kind of a broad scope, is to kind of look for anywhere, any type of sources, any categories of sources in any language at any scale, for example, and at any resolution, and then make them available for use towards like humanitarian missions, for example. And as I said, this is just an example of the current scope of the data the points of interest data that we have created. I think it's around 275 million POIs in this picture. And we've been kind of putting together efforts for the last 4, 5, 6 years, I think now. And there are around 12 or 13,000 categories, from schools to hospitals to warehouses and things like that. And this data, basically, I'll take kind of a more like a reverse engineering approach, how we came here and how this data then can be translated into helping some of our first responders. So besides kind of there's a lot of research opportunities when you have this kind of data. Kevin talked about the temporality of the points of interest data, where you can use like check-ins or open and close time of points to enable this. You can look from population dynamics, for example, how to put people where there is a place. Co-location pattern mining, some of the research trying to understand and characterize neighborhoods, for example, or conflation, for example, like different kinds of data that you put together, how you conflate them, as well as creating final resolution land use maps, QA/QC on these data. I'm particularly interested in spatial network, which is more like a higher order dimension of POI data at some scale, like Dave, for example, talked earlier in the talk. Can you complement this data with some other data, like ground level imagery, for example, or place popularity? For the purpose of this research, I'm just focusing on the disaster research that we're going about. So really the way to collect the data is like we look at the entire planet, and we divided this planet into like continents, like the way we know it. And then we have computational systems that basically are allotted to these areas, and their job is just to look for any new data, any data that you can get from all these places, including remote areas, islands, countries, everywhere. And when you look at the entire continent, even with amazing computational resources, it's such a large that you really have to come up with some smart ways to scan the entire planet. So Kelly and Kevin and we basically at the very beginning of this project tried to come up with an idea of how we can use some of the existing resources that we have at the lab, like Landscan data, and can translate a simple population distribution into a gridded network. Now, like there are people, there's data. It means there are POI as well. So we basically did like a population density distribution and then divided that into like uneven area grids, for example. An example is here is shown is for Yemen. And once you get these grids, basically what we did is we took a large grid, and if there's more than 50,000 people in that grid, we divided that grid into 4, and then we retreated this until we end up with less than or equal to 5,000 people. So now we have the entire planet in a dynamic geo-gridded architecture, and now we can assign these grids to a lot of computational resources, and their job is now to collect and look for any new data that's coming in. So the level of efficiency that we achieved using this kind of is just shown by 3 different examples here of 3 different countries. If you look at simple 5-kilometer geogrids, for example, you can see like for example, how this looked like. But if you get like 1 kilometer count geogrids, like a fishnet, for example, you get 743,000 or like over 1 million in Egypt. You get a 5K, you still kind of get a lot of that. So we try to kind of optimize that by using this uneven geogrid data set for this to start collecting a lot of these data sets. So when you start collecting the data, let's say now you collect a lot of data. One of the challenges that we also faced early in this research is how to coherently map and collect this data and create a high quality data sets. What I meant is like if you're getting data from Facebook, they say, oh, it's a Mexican restaurant. Google will say it's food. Wikimap here will say it's a Ryan's restaurant, or someone will also say like a hotel, for example. So I used to work with Rachel Palimbo, and she did a fantastic work of coming up with this multi-level category mapping of POI across all the different sources that we collect. So at the very top level, you have like residential, non-residential, and public. And then below, you can have another categories like schools. Within schools that you can have like public schools or private school. And within that, you can have like middle school and primary school. So you can actually look for a specific data for the entire planet based on just the category, and you can say, hey, give me all the primary schools or give me all the kindergartens, and it can query and you can get that kind of a data using like AOI, for example, as well. So irrespective of what the data source is, we kind of normalize that across the different sources. And once you do that, you can use this data for a lot of research. Like, for example, Kevin showed some of the dynamic temporality work that, for example, goes in. So this is kind of just another example of like how that network of 13,000 categories are managed. At the very top, you have administrative, residential, and non-residential. And there's another program at the lab, population density tables, led by Marie Urban. So we also get some inspiration from some of the work that was done in that project as well to build this kind of a network graph. And then, for example, within non-residential, you have, say, entertainment, you have theaters, outdoors, sports. So we then embedded all these different layers of categories into all the POIs that we have collected so far. And that kind of normalizes irrespective of that. Another challenge then we had was, since we collect a lot of POI, there are a lot of duplication happening. So how we can reduce the duplication? So there's also another research work going on at the lab where we use DB scan and some of the semantic analysis work, for example, name, categories, language, and other cultural constraints to merge and combine POI to create like really high quality data sets, including like if you get more than one data set, more than one POI for the same type, we basically also create some kind of a ranking or a confidence in that data. So this is just an example of when we ran this kind of algorithms and build this kind of data set, what was the reduction we achieved over a course of time. And Joseph Bentley basically is one of the key researchers who basically developed this algorithm, and we're in the process of submitting this work at one of the conferences. But this clearly shows, for example, how you can create some really good quality data sets using different combination of categories and types. So then once there's a lot of other things that comes into play, for example, translation of languages, address mapping, geocoding, and all those research also came into conclusion. But I just thought maybe I can use this opportunity to also showcase some of the work that our team did recently to map the explosion in Beirut. And some of you might know, or a lot of you have seen that video of how a chemical plant exploded near Lebanon, Beirut. And I think it was like 2,750 tons of nitrate was exploded, and it created a very big damage to the nearby surrounding areas. And it was basically an incremental reduction in damage, but still, since the material was different, the type of the buildings were different, it was very difficult for us to create a good data set of understanding of what was damaged there. And what we did is we used some of the infrastructure that we have to create these data sets from different sources, and then we combined with some of the NASA imagery to understand and map how the damage happened for that period of time. So if you look at some of the data that we collected at that time, the Facebook had 2,000 POI. I think it might have more at that time. Foursquare, Google, and here, and some other sources that we have listed here. So kind of collectively combining over a few 100,000 points. And once we get this data, some of the challenges, some of the scientific challenges that I discussed earlier was to conflate this data into a point that we can properly check. At the same time, which of the points that we think are more strategic? Is school important, or a hospital important, or a playground important, or a restaurant is important? So we kind of also identify some of the categories of these POI on which of these are more important and which are more strategic in terms of saving lives or using them as a temporary shelter, for example. So some of the space-time constraints that we identified, some of the social media chatter that we combined to understand and create a signature for these data sets as well. Some of the results. So there's a lot of geospatial analysts who, besides using machine learning and artificial intelligence, also we have like a human in loop confidence creation, where really kind of we look at the point from 4 different sources. We use overhead satellite imagery, and we try to come up with some kind of a confidence on the data. And if you look at that, it's impossible to do all the data in a short amount of time. So that's why we subsample the data in a way that is still achievable and can create more impact. So is the name correct, for example? Is the location correct? Is the POI right on the smack on the building, for example? And this ranking changes all around the world. So we really have to be more spatially explicit when we do this kind of research. So this is kind of, when we reviewed the points, this is one of the results that we came up with. So we basically, when you look at the distribution of confidence that we look at, it's just all over the place, because the nature of the categories were more important than the spatial distribution of those points for this kind of an effort. And as you look at that, some of these points are really good. Some of them have a high confidence. Some of them have a low confidence. So they are, again, all distributed just all over the place. But there's a lot of kind of complementary effort that goes in. For example, we get a lot of social media ground photos where people tweet, for example, and we have NLP-driven algorithms to get recent tweets, for example, and translate some of the pictures into, characterize them into specific words, for example. Or we can look at some of the complementary data that we get based on news and other channels as well. So this kind of allows us to cross-compare and use a second line of evidence when we create these data sets. Some other information, like, for example, like from news channels or from video channels, we also try to capture that in order for us to create a good quality and important data set, for example. That way, we understand the need to kind of have this data set. So in this example, we kind of reviewed close to 2,000 points. Once we reviewed them, we got 156 POI confirmed damage based on our assessment of this work, like maybe looking at ground photos or satellite imagery or looking at some of that information. We also use, as I mentioned, some of the inferred area data. So we basically conflate and intersect some of the damage models that are out there through NASA or some other agencies, and we kind of see if these POI are in the path of destruction, for example. We do the similar things like for hurricanes or for other natural disasters like flooding, for example, in Puerto Rico. And we create some kind of a total input damage and the confidence of how we believe of all these data sets were affected because of this this work. Okay, so this is another example that we did for Bahamas, and similar efforts being done to understand. This time, instead of explosion, we looked at the Hurricane Dorian. So this right figure you see is the yellow line is the path of Hurricane Dorian, and we look at the Bahamas, Marsh Harbor, and some of the areas, some of the scenarios I showed earlier, to examine the impact of hurricane or any natural disaster towards creating a more reliable data sets, for example.